types of fault. What is meant by fault? Fault in power system, that is, it is a deviation of voltage and current from nominal values or state. A power system fault, it may be defined as any condition or any abnormality of the system which involves the electrical failure of primary equipment. What are the primary equipments we have in power system? We have generators, we have transformers, bus bars, motors, cables, etc. So these are called power system primary equipment. If any fault occur in those equipments, then surely it will affect the power system. And what is the need for fault detection actually? Fault detection is necessary to select or design suitable switchgear equipment such as electromagnetic relays or circuit breaker and other protection devices. Once you know the type of fault, then only we can identify the then only we can choose the power system protection devices. So what are the power system faults we have? We have that is a fault. It can be classified into 6: transient fault, permanent fault, symmetrical fault, unsymmetrical fault, open circuit, and winding fault. What is meant by transient fault? The transient fault which is not permanent, that is, and which does not affect the insulation permanently, do not damage the insulation permanently, and which allows the circuit to be safely and re-energized after a short period of time. It may be 1 second or 2 seconds time. It may get automatically re-energized, and mainly it occurs in outdoor equipment. Wherever we are using air as the insulating medium, in that case only the transient fault will occur. Example for transient fault is insulator flashover following a lightning stroke. Transient fault which is not permanent. Then next one is permanent fault. So just which is opposite of transient fault, permanent fault which affects the insulation permanently. And in this case, it should be replaced or repaired compulsorily. That is, equipment has to be repaired or replaced. What are the common causes for this permanent type of fault? It may be due to overwind, or it may be due to ice loading, or it may be due to thermal heating, or it may due to some rare events like trees growing into lines, or due to earthquake, or due to flooding. These are permanent fault. Next one is symmetrical fault. From the name itself we can say symmetrical, that is, it gives symmetrical current. That current, fault current is equal, as well as which is displaced by 120 degree in all the three phases. All the three phase current, fault current are equal with 120 degree displacement. And symmetrical fault, it may be three phases are short circuited to the ground, that is the first diagram, or it may be short circuited without involving the ground. Because of the balanced nature of fault, that is because of the equal fault current and equal displacement, for a calculation purpose, we have to consider only one phase. That is, only one phase need to be considered for fault calculations. And mostly these type of fault occur only 2 to 5% of the system faults. That is, due to only 2 to 5% of faults are symmetrical fault, but which affects system very severely. If this fault occurs, system remains balanced but results in severe damage to the electrical power system equipment. So these two are the symmetrical faults. Next one is unsymmetrical fault. Unsymmetrical fault means unequal fault current and unequal displacement current. This unsymmetrical fault, it may be classified into 3: LG, that is, L represents a line, G represents ground. So single line to ground fault, or it is a line to line fault, or it is double line to ground fault, LLG. In this diagram we can show all the type of faults, that is single line to ground fault, and line to line fault, and two lines to ground fault, and three phase line fault. First one, single line to ground fault. From the name itself we can say single line to ground, a short circuit between any one of the phase. It may be due to R, or it may be due to Y, or it may be due to RYB. That is a short circuit between any one of the phase, line and to ground. This is due to failure of insulation between conductors. That is, in between, this is one conductor and this is second conductor, it may be due to failure of insulation, or It may be due to breaking of conductors and falling to the ground. This diagram shows that case. Due to the breaking of conductors and falling to the ground. This is single line to ground fault. Next one is line to line fault. A fault occurs between two phases, any two phases, RY or YB or BR. So line to line fault occurs when two conductors make contact with each other. That is due to heavy wind or due to swinging of lines due to winds. These two lines, it may touch each other, causes the line to line fault, a short circuit between any two lines. Next one is double line to ground fault. A short circuit between any two phases and ground is double line to ground fault. The occurrence of this type of fault is 15 to 20%. Next, this table shows the fault statistics. So here very less option is 3L, that is 3 phases. Fault occur between 3 phases is only 2 to 3% only, and double line to ground fault is only 5%. Then line to line fault is 8%, and mostly occurs single line to ground fault, that is 85%. And next we are going to say about open circuit fault and winding fault. Open circuit fault, which is nothing but opening of one or more conductors, that is open circuit fault. In that case, unbalanced current flow through the system, thereby heat the machines, thereby heating the rotating machine. What is the reason for open circuit fault? It is due to breaking of the conductor, that is open circuit fault. Next is winding fault. Winding fault, which is nothing but fault occurred in the windings of generator or transformer or motors. That is short circuiting of turns is called winding fault. Thank you.